Friends, welcome to my YouTube channel. Dhanesh here. In the last video, we were discussing about transformer neural networks. In this video, I am going to do an implementation for transformer neural network using PyTorch. Let's start. I will close this, okay? After that, we will get into that. Fine. Transformer implementation. This is the second video. You can watch the previous video to get more clarity on transformer. Just I am giving some introduction about attention to get more idea about transformers. This is the attention we are using in transformers to solve the problems of RNNs and LSTMs. To solve the problems of recurrent neural network and long short-term memory networks, researchers created a technique for paying attention to specific words. Attention is a technique that is used in a neural network. For RNNs, instead of only recording the whole sentence in a hidden state, each word has a corresponding hidden state. That is attention. Each word has a hidden state. That's the difference we make in transformers. The idea behind it is that there might be relevant information in every word in a sentence. That's why we need to have hidden state for each word. So you may be familiar with hidden state, forget gate, remember gate, all these aspects. If you are familiar with LSTMs and recurrent neural networks, you can just learn those technologies like RNNs, LSTMs as well before getting into transformers. It would be good. Fine. Transformer introduction. This is a simple introduction. The Transformers is a deep learning model introduced in 2017, used primarily in the field of NLP. We are using extensively in the field of NLP. Transformers are used. To solve the problem of parallelization, transformers try to solve the problem using convolutional neural network and attention model. We can tell transformer is equal to convolutional neural network plus attention model. Combining these two, you will get the transformer. To get more clarity, you can watch my previous video related to transformers. This is here I am mainly focusing on the implementation using PyTorch. Fine. This is the architecture of transformer. This part, the first part is the encoding part. Here this is the decoding. So in the architecture, if you see here, we are using the multi-head attention. There are different types of attention models in this architecture. I am using the multi-head attention, and we are using the the module consists of a multi-head attention plus feed-forward neural network. When you see the encoder or decoder, this is the encoder, this is the decoder. If you whether it is encoder or decoder, it must contains the multi-headed attention. Please watch the previous video to get more clarity about different types of attention. Multi-headed attention plus a feed-forward neural network. Neural network we will use. Multi-headed attention plus feed-forward neural network is this is the thing. It contains multi-headed attention and feed-forward neural network, whether it is the decoder or the encoder. When it comes to the decoder, we will include the activation functions like softmax and linear. See, the softmax function gives the output between 0 to 1. That means it will give the probability value between 0 and 1. So you can use those things in the decoder part. Now Now what I am going to do here, see what I am trying to see, you understood the architecture. So this is the architecture of the, here I am just, to get more clarity, you please watch the previous video. The multi-head attention, this is what, we do. Instead of only paying attention to each other in one dimension, transformers use the concept of multi-head attention. See, multi-head attention means it consists of several attention layers running in parallel. That's multi-head attention. This is the multi-head attention architecture. It contains, several layers running in parallel. Fine. This is the math of attention. See, we will be using in our implementation also. Q is the matrix that contains the query vector representation of one word in the sequence. K is the all the keys, that is the vector representation of all the words in the sequence, and V is the values, and dk is the dimension of the key vectors used. Then this is the formula for the attention. Attention is equal to softmax of q k raised to t divided by root of d suffix k into v. So this will be the, see, when we talk about the y is equal to w into x, then this is the weight. Here the weight will be this term, and this is the x, and this is the output. You are getting me? So this is the math. So that's why the weight is equal to, this is the formula for weight. So you understood these aspects, the math of attention you understood. Here the weights are defined by each word of the sequence that is influenced by all other words in the sequence. We are using softmax function to get an output between 0 and 1. See, now I am getting into the PyTorch-Transformers for the implementation. PyTorch-Transformers is a library of pre-trained models for NLP. Fine. See, there are different models for NLP task. BERT, that is, bidirectional transformers for language understanding. GPT from OpenAI, released with a paper improving language understanding by generative pre-training. GPT-2 from OpenAI, Transformer XL from Google, and XLNet from Google, XLM from Facebook, all released together, for NLP tasks. So these are all the tools. See how this is the way we install the PyTorch transformers. Pip install PyTorch-Transformers will work. The predicting the next word using GPT-2. See, PyTorch-Transformers support many NLP models that are trained for language modeling. It easily allows for natural language generation tasks like sentence completion. See, this is NLG. Here we are using natural language generation. So task like sentence completion. GPT-2 is a transformer based generative. See, here I am using the implementation. GPT-2 is a transformer based generative language model that was trained on 40 GB of accurate text from the internet. It contains 40 GB. Being trained in an unsupervised manner, it simply learns to predict a sequence of most likely tokens that follows a given prompt based on the patterns it's learned to recognize through its training. So here, see, for example, in our model, see, if we give the sentence, what is the fastest car in the, then it will predict its word, like that. That's what our program does. You can do with any other, sentence as well. It will predict. I will show you the program. I am doing it in, I will use Google Colab. See, you may be familiar with Google Colab. To get Google Colab, you can just go to Google and type, Google Colab. Then you will get this Google dot research, so collab.research.google.com. So you just click on this link, you will get the Google Colab. It's built on top of the Jupyter Notebook IDE. So I am clicking on new notebook, then it will come. So this is the, it's built on top of Jupyter Notebook. So it is Google Colab. Now what I'm going to do is see, to get an idea, see, I will connect to this runtime. We need to change the runtime, change runtime type. from to GPU. Here you will get 13 GB of RAM. Google Colab is providing. We will save it and we will connect it. That's all. Then it's a lot of a RAM capacity. Even your local machine, you don't have much space, you can go with this tool. It's a very nice tool for training the models. Fine, it's connected. You got a green arrow here. It's connected. Fine. Now I have already the program here. Before that, what I need is the pip install PyTorch-Transformers. This is a new window here. I will use this command to install pip install PyTorch-Transformers. I will install this here. So I am going to install. You can see here. Just click on this play button, then it will be installed. See, it's downloading. You can see here it's already, because it's telling requirement already satisfied. So this is what we are because I have already run installed by here. So what we do here, I will we in this program we tokenize the index, the text as a sequence of numbers, and pass it to the GP2 LM head model. That's what we do. This is nothing but the GPT2 model transformer with a language modeling head on top, linear layer with weights tied to the input embeddings. So this is what our program do here. So this is the comment session here. You can include text in the Google Colab. So we tokenize and index the text as a sequence of numbers and pass it to the GPT2 model. That's what we do in this program. Fine, I will run the program and I will show you how we can predict, we can generate text. See, actually, see NLP, when we talk about NLP, you are familiar with this concept. This is a very important thing. I can tell you, like NLP is NLU plus NLG. This is the formula, right? NLP means NLU plus NLG. NLP means natural language processing, NLU means natural language understanding, and NLG is natural language generation. Here our program, it's used for NLG. We are doing natural language generation here, implementation of natural language generation using transformers. Fine. See, we installed PyTorch transformer here. Next I will try to run the program. Here I have the program here. We have done the pip install PyTorch transformers. Now I am downloading the I am importing the packages here. Let me run here. It is code. It is I am pasting it here. You can see here. So if you see the code here, it is importing torch from PyTorch transformers, import GPT2 tokenizer and GPT2 LM head model. See, tokenizer here, we are loading the pre-trained model tokenizer vocabulary here by using the GPT2 tokenizer from the pre-trained model. So our text is what is the fastest car in the, so the program has to predict the word world. So that's what we need. So here we are getting the indexed underscore tokens from the tokenizer. So just I am running this piece of code. Let's see how it's going. So it's yeah, it's downloading the necessary libraries for the GPT2 tokenizer. It will do. Yeah, it's done. Now I am trying to copy the remaining part of the code. It is, we will convert the indexed tokens from here, and we will train the model in this piece of code. I will show you here. So what I am going to do is just I have pasted here. Let me run it. So it will show the model how it's here we are converting the indexed tokens in a PyTorch tensor. Tensors are, multi-dimensional arrays. They are, containers for data. We have here, 2 and 3 dimensional containers for, data. So this is we are loading the pre-trained model weights, and we set the model and model here. So that's what we are downloading the necessary data here. So let's see how it goes. See, yeah, it's showing the model as well. See, it's showing the layer number, its block, every details it's showing here. When you are doing neural networks like convoluted neural network, and so that will give the model summary, right? In the same way it's giving all the details related to our model. Fine. Now we will try to execute the remaining part of the code. It's really interesting actually. Yeah. Now if you have a GPU, put everything on CUDA. So you are familiar with this. So we are going to put everything on CUDA from the GPU. So I am going to run this piece of code and see how it goes in the Google Colab. Yeah, fine, just run it. Yeah, it's not giving any error. It's fine, it's done. Now the next part, we will try to predict the portion. See, get the predicted, we will try to predict the next word in this. So this is what we are going to do now. In the next we will next cell, I'm trying to execute the code. So we need to get, see, our input sentence. You need to understand our input sentence is what is our sentence, what a text is. We are trying to NLG, we are doing what is the fastest car in the, so the program has to give what is the fastest car in the world. So let me run this piece of code. This is the thing, right? Okay, let's see how it goes. Yeah, see, you can see the output. What is the fastest car in the world? So we will change that sentence and try to run it once again. I am just giving here, what is the fastest bike. Instead of car, I am going to give what is the fastest bike. In the just I am trying it from here. So it is so it will it's run, it's executed. Now we will run it here. Let me see. Yeah, it's running now. Fine. Then here we need to put it in the put everything in the CUDA. So it's running now. Now I am again here this cell I will run it. See what is the fastest bike in the world. Then I will change. I am changing the entire sentence here. I am giving it as this sentence I am giving. You see it here. I am giving light is a form of, then you are familiar, it's a form of energy. That's what it has to give. Light is a form of, so we need to the NLG, that is the natural language generation. There the completion should be energy. Let's run this. Is it giving energy or not? It's executed. Now we will convert the index tokens in a PyTorch tensor. It's also, I think it's executed. Okay, it's running. Yeah, done. Now we will put it in the CUDA. It's done. Now we will execute this. So we need to give light is a light is a form of magic. So it has to, light is a form of magic, that's what it's giving. So actually, frankly telling, previously while I was running this program, it was giving light is a form of energy, but now it's giving like light is a form of magic. So you can run in your own way. So sometimes it will give different predictions, but previously while I was running this piece, it was giving light is a form of energy. Anyway, so this is the way the PyTorch transformers can be used for NLG, natural language generation. NLG means natural language generation, natural language generation, that is NLG, you know, right? NLP plus NLU plus NLG. So there is separate videos for natural language generation as well in the playlist, you can watch it. Fine. So that's all about PyTorch transformers and its implementation. Thanks for watching. Please like, share and subscribe. Thanks a lot. Thanks a lot.